Hello, and welcome back to the AI Research Roundup. I'm your host, Alex, and today we're diving into a really interesting paper called KAG Boosting LLMs in Professional Domains via Knowledge Augmented Generation. So this paper introduces a new framework, KAG, which stands for Knowledge Augmented Generation. It's designed to improve how large language models work in specific professional areas, like e-government or e-health Q&A. The main idea is that current methods, like retrieval augmented generation or RAG, have limitations, especially when dealing with complex knowledge, things like numerical values or specific rules. KAG aims to fix this by cleverly combining knowledge graphs with the usual vector retrieval, making the whole system better at reasoning and providing more accurate answers in these specialized domains. They actually show some pretty significant improvements over existing state-of-the-art methods. Okay, so Figure 1 gives us a nice visual overview of this KAG framework we were just talking about. On the left side, you can see the KAG builder. This is basically the offline part. It takes documents, runs them through an indexing pipeline, and builds up the domain knowledge base. Then, on the right side, that's the KAG solver. This handles the online query answering, using things like logical forms, retrieval, and reasoning, and planning. And supporting both of these, down at the bottom, is the KAG model, which enhances the core language understanding and generation capabilities needed for the whole process. Okay, so building on that overall framework, Figure 2 zooms in on a key part, the knowledge representation they use, which they call LLM FRIS PG. What's really interesting here is how it separates things out. You see that line dividing knowledge, which is static and predefined, from information, which is more dynamic, like raw text chunks. It shows how specific instances, like a person, can link to both this structured knowledge and also to the supporting text chunks, and how these instances relate to broader concepts, like taxo of person. This structure is designed to be, friendly to the language models. Right, so we talked about the structure of the knowledge representation. Figure 4 actually shows us the pipeline for how they build it using the KAG builder. You can see it starts with the raw documents, like PDFs or text files. Then it breaks them down into meaningful semantic chunks. From there, it extracts key information, like entities and relationships. And then, importantly, there are alignment steps to connect this extracted info, both within the documents themselves and with broader concept graphs, before finally putting it all together into that domain knowledge graph ready for use. Okay, so after seeing how the knowledge graph is built with the KAG builder pipeline in Figure 4, Figure 6 gives us a concrete example of how it's actually used to answer a question. What's new here is seeing the process on the right side, how a user's question first goes through logical form planning. You can see it breaks the question down into smaller logical steps. Then, it uses those steps for reasoning and retrieval, pulling information from both the structured graph and the text chunks before finally generating the answer. It even shows a loop, suggesting it can refine the process if needed. So, Figure 6 showed us the step-by-step process of answering a question using the KAG solver. Building on that, Figure 7 zooms out a bit to show the core model capabilities that the KAG framework relies on. What's new here is how it explicitly breaks things down into natural language understanding, or NLU, natural language inference, or NLI, and natural language generation, or NLG. You can see how NLU helps with extracting information and understanding the user question. NLI handles the semantic alignment and reasoning, and NLG focuses on generating the final answer, all interacting with that central knowledge graph we talked about earlier. So bringing all these pieces together, the KAG framework really offers a structured way to ground large language models in specific complex domains. The key takeaway is how it systematically builds and uses knowledge graphs, blending structured data with text. This is really important for making LLMs more reliable in professional areas, where accuracy is critical. Well, that's all the time we have for today. Thanks for tuning in to the AI Research Roundup. I am your host, Alex. Catch you next time.